Hi guys, we are in a machine shop. And yeah, so I'm going to show you guys. Okay, here we go. So this is my assistant today, Dan.
Nice to meet you guys.
And so here is the lathe that we're going to be working on today, and also the mill. So as we go, feel free to ask any questions you might have. And we're just going to kind of talk through the thought process of doing some of the machining here. So we're going to start off here on the lathe. One thing I'll note too is like safety is of utmost importance. So you'll see Dan has his glasses, very, very important. But if you don't have glasses, you should have safety glasses. So I have a pair of safety glasses on. There you go. And a lot of times they'll be offered in the Purell. And then you just want to make sure you don't have any loose jewelry or anything as you're working on the lathe. It's a very, very dangerous machine because your workpiece and everything is going to move right there in those jaws of the chuck at a very fast rate. And you can see here there's no guard or anything, so you're right up close to the machine. So you just want to be careful of that. So we might talk through, as we're setting up here, the different controls on the lathe, as well as what all the different parts are called. So we have the chuck we're talking about over here. We've got our tool holder, which is this guy. And then we've actually got the tool that we're using on the edge here. It's a carbide. So this comes out and then locks back in. And depending on what kind of operation you want to do, facing or on the front of the piece, or if you want to do turning on the side, you can adjust that. So Dan has it set up right now, so it actually can do both, which is very convenient because it's at an angle there. So you'll see that shortly. Over down here, you want to put the piece in?
Sure.
We have the tailstock. Yeah, I'll show. Which is what you would use if you're trying to do any kind of drilling, or if you need to hold a piece on the outside of both sides. So you can hold a piece here if the piece is there, and then also hold it on the other side with a dead center. So we're going to now mount our piece in the chuck.
Can we hear them?
You can hear them. Yeah. They're not talking yet.
All right.
But seriously, feel free to ask any questions as we're going here. So basically what he's doing right now is he's tightening the chuck around the piece. You want to hold it nice and tight. And then now moving over to the controls. Dan, you want to talk us through what you're doing?
So basically, this isn't a variable speed lathe. The motor turns at one speed. So you only get a set number of speeds, if you guys can see here. So you have a high and a low speed, and then 4 speeds within that. So currently we're set to D 175 on low is what we're going for. So we have it set over to low. Can't move these. They're kind of like it's like a manual gearbox, but there's no clutch. I don't know if you guys know how to drive stick, but basically you can't shift these while the lathe is moving. So you got to calculate what kind of speed you need beforehand and just choose the closest one. This is your cross feed, in versus out. And it's actually your auto feed. It does both cross and axial feed. And then this tells you, this chart here, this very sophisticated chart basically tells you how they relate to each other. So how much it will move for every time the spindle turns a certain amount. Then we can get into the actual kind of on-off of the lathe. This is the power switch. This is the emergency stop button. And then it's actually just the general stop. And then this is for coolant. This kind of lets you test the lathe, and then there's a separate switch further down. So that's the controls there.
Any questions so far? Okay. All right. Well, then he's going to start setting up. So he's getting in.
So a lot of times you'd want to indicate this component in. For time's sake, we won't. I'm actually going to shift the gearbox while it's not on into neutral. So in between the gears, and now this spins more freely like that. And what I can do. The compressor's on right now.
Yeah, it's on for the laser.
You can leave it on.
You need it?
Yep.
Okay, cool.
Thanks. So usually you'd indicate this in, but we're not going to do that this time. So what I'm actually going to do is kind of just bring the tool close. And actually, Lisa, if you want to get a vertical view there. And so what this lets you do is see how centered the piece is with respect to the tool. And as you can see, it's very close, but it's not touching and it's not opening up a gap. So the piece is very centered in the chuck. It can actually be out, so you'd see a gap open up and close as it spun. So that's pretty good. And then on this face here, you can see it's blue. I've actually coated it with Dicom, which is a layout marking fluid that lets you see, basically dyes the metal so you can see where you've either marked the metal or removed metal. So that'll be a good illustration. Even though this looks like it's pretty good, you'll see as we touch it off and face it, it won't actually be removing material everywhere. So it's a good
it's a good practice.
Yeah, it's good. It's good practice, and it'll also show you like the imperfections of the machine. So yeah.
All right. Any questions, guys, before we get started? All right.
Chill. So I'm going to go with facing first. So let's see. Before I get too far into that, actually,
sure.
So this lathe doesn't have a digital readout. So how you measure, if you're trying to be precise about how you're measuring, you have these scales which you can adjust. So like from this position here, this reads out in hundredths of an inch or thousandths of an inch, and basically these are tens of thousands. So I go from here to here, and I've just moved the sled 20 thousandths of an inch, 40 thousandths of an inch. If I want to say, okay, that's my new zero spot, I just rotate this back to zero. Same with the lower scale. You can see for the cross slide there, that's lower scale. So it takes some talent.
It just takes some practice. But yeah.
So all right, I'm gonna get started with
facing.
Yep.
So you're just going to go across the face, so you'll see that some of the blue dye will disappear as the material is removed, but some of it will still be there.
So now what I'm doing is I'm positioning the tool so I know it's going to touch off on the face, and that'll let me know right when I get to the face, because right now it's an unknown distance, right? Is it 1 inch? Is it 1.5 inches? I just kind of tossed it in there. So what I can do is I can bring it in, and if I was trying to be really precise, I would actually, once I touched it, I would set that rotational scale to 0. So there, I've touched it off. Now what I can do is actually I'll set my scale to 0, and then back it up, come off of the part. Now I return to that 0 I just set, and now I can start going across.
So basically you set your 0 so that as you keep going, you know how much material taking off each time. There's only a certain amount that you want to take off per turn. So you can see now that we're starting to lose some of the blue dye as we move across, which means that we're removing material. You also might be able to see there's a little bit of steam, so the part is getting hot. So sometimes we'd use cutting oil to cool it down. So he's just being very careful to feed it at a very deliberate rate and make sure it doesn't heat up too much or put too much force in the area that we're working. So you notice he only has to go halfway into the part because it's spinning all the way around. So by going all the way into the middle there, he's actually touched the entire thing off.
And I don't know if you guys can see, but you can see how the blue's like kind of wobbling around there, and there's still some blue left at different locations because there are low spots. So I haven't machined there yet, and it was a little uneven. So you can really see that spinning in the lathe there. But if you come to the side, you can see as I go there, it's actually perfect with respect to the axis. So that's just kind of an illustration of how the piece is kind of imperfect, but as you lathe it, it will true up with respect to the lathe's dimensions. So
he's going to go in again, and this time he's going to be looking to go a little bit farther than a 0.
So I'm going to 5 thou.
Okay, so we're going 5 thou.
You can see that here.
It might not focus that well.
It may not focus, but that's where I'm setting that depth of cut. And then I just come back across here.
So you can tell that by the chips that come off the part. So when they're blue, that means it got really heated up. But you can also tell by how long they are, how stringy, whether they're good chips or not. And that's something that you just kind of get used to. Machining is also a lot about hearing the sound and making sure that the sound is a good sound to hear. So you get kind of more used to that, but you'll want to know if you're going too fast or too slow based on what you're listening for. So now we're going into the center again. So you just finished going off the part, and now it looks like all the die-kin is removed. So yep. We officially faced the entire part. So we can say that that part is now flat relative to the lathe right now in its current setup.
And so now what I'm going to do is I'm just going to do an example turn, and you guys will really see here where, especially after the spindle stops, where it wasn't perfectly centered. So we're going to cut a circle that's perfectly centered to the lathe, but maybe not the part. This is just the outside of this component. It's not a critical dimension. So again, I'll bring it over where I know it's now from this face here. I know that if I bring the tool forward, it's going to touch. So I'm going to touch it off, and then now I'm going to do the 0 on the Y and do the same thing again.
So you can hear when it touches.
So now what I can do is bring this back in
to 0.
And I'm going to go like 0 here. Now I'm going to go 5 thou or 6 thou farther. Actually.
So now he's going in on the Y direction. And when you're on the Y direction, so you're going in a certain amount, like radially, but then you have to remember too that since you have a whole diameter, when you're removing material, if you go in a radius, you're going to actually double the material removal across the entire thing. So that's important to remember if you have a critical dimension and you're using calipers to measure it the entire time, that you want to make sure that you're aware of how much material you're removing each time.
So I'm just taking off a couple thou here, and it shouldn't look like anything's happening because basically nothing is happening. And then I'll actually back this up and stop the lathe.
Cool.
And I don't know if you guys can see, but as we spin this part around, the tool was only machining like here. You can see it's kind of shinier there. And then it doesn't really look like it was touching off anywhere else. So we were just a few thou out, and it was just skimming there. So if I start the machine back up and then take a deeper cut, that will get exaggerated.
Any questions, guys? All right. Hopefully you guys can hear us okay. Okay, good. So this time you can see he's actually removing more material.
And you can see it's kind of flashing. And that flashing is where we're seeing a part that's high enough to be cut versus a part where it's not. And so again, you know, it's a perfectly cylindrical piece, but I chucked it up in the lathe and it's only machining. You can see it's been machined there, but it's not being machined there. So.
Yeah. Is that all making sense to everybody? Turn the camera around.
So
awesome.
That is kind of how you would, and I guess I'll make a full turning pass and then we'll call it there.
It's also worth mentioning too that you can set the direction, so counterclockwise or clockwise of the machine, and that's going to depend on how you're actually, what movement you're making across it. So we'll talk about that a little bit with the mill too, but you want to make sure that your cutting edge is actually in the direction that you want it to be. And we'll talk about that a little more. So now it's a bit more obvious. Again, we're removing more material consistently. When you see the flashing, you're seeing a lot more defined band. So now Dan's going to do a smaller section, but go in a little bit more just so we can see what the cylinder that's been completely machined would be like. Completely turned down, I should say. So now we have this nice consistent band.
And you can see the band is consistent here, but it's not consistent where we were machining before. So you can see this is machined, but as we turn it around, this was machined, but this wasn't machined, even though it was in the same region. And that's just because it's not perfectly centered. So it's just something to keep in mind.
Well, and your stock material is not going to be perfect either. So I think we talked a lot about that, and that's what we kind of wanted to communicate with this, is that your stock material is not perfect, and that's why you have to buy stock material that's oversized, because you can't take for granted that it's going to be of any certain quality. So hopefully that kind of communicates that. So awesome. Any questions or thoughts? No questions? This is good so far? Fun content? Okay, awesome. Cool. Sweet. All right, so you want to switch over to the mill?
Yeah, we'll switch over.
All right, so we're gonna switch over to the mill. So one really important thing I want to highlight right now that Dan is doing of utmost importance is he's cleaning. So that is really, really important when you work in any kind of communal space, that you want to get those chips out of there, so that the next person who's going to be machining after you.
Also, the cleaner the machine is, the more accurate it is. So a lot of times before you start working, even if it's clean most of the way, if you're going to do something really important, you really want to make sure it's clean.
Yeah. So this is not the best example. I think most of the PRL lathes are usually cleaner than this. This one is kind of a little gunked up, but we're in a more of a community workspace, so you kind of lose some of that accountability. When you're in the PRL, we have every student do a shop job after they've done their machining. And so that'll be something to sweep a certain area or whatever after cleaning up your own space as well. Because we are a community and we want to make sure everything is nice and clean and that you guys can do precise work when you need to.
Okay, so kind of on that cleaning note, and then we'll get into milling, you can kind of see there's this like gunk in like around the vise, in between the vise and the table. And you can imagine if you didn't have the vise on the table and someone left the table dirty and you put that on the vise on top of this gunk, the vise might be, tilted. And then when you put your piece in, the piece will be tilted as well. And then you make the machining, you do your machining passes and nothing comes out correct or what you expected it to be. This is a pretty imperfect work piece.
Yeah, so we'll just show you guys for reference here.
Like it is not square at all in any of the directions. This is kind of like a lot of mechanical engineers will call this like a potato because like none of these surfaces are really that great. So we're going to choose the best one. In my opinion, it would be this surface here, but you can see there's this like dent at the bottom, which meant if I put it on this, it's actually tilted. When I put it on a flat surface, because of the dent there, it's actually tilted this way ever so slightly because that's a raised spot. So actually what I'm going to do to kind of recover this piece is I'm going to hang this high spot here off of the vise. And then when I tighten the vise down, it should be like close to straight across on the bottom. And that's kind of, when you're first setting up like a rough piece of stock like this, that's what you want to do. So
so normally you would go through a process of picking out parallels and putting them under the piece, which help. Well, I mean, you don't always need to, but it can help you make sure that the piece is seated properly. But because this piece is so inconsistent, we're not going to actually worry about that until later. But we're going to square down this piece. So right now, Dan is inserting the collet, which also has the shell mill that we're going to use. And so that's a facing end mill that we're going to use. And so he's putting it in. And then at the top, he's tightening, and I'll try and see. I'm not very tall. There you go. You guys can see that, hopefully. So he's tightening the crossbar. Drawbar. I always get the name wrong. And so that is to make sure that all of this is held in together well. So that's what we're doing right now. And he's tightening it down. You guys will learn more about this when you come in to do your first milling lab, but you want to make sure you don't over tighten it. but you also want it to be nice and secure.
And then one thing we haven't covered here is kind of speeds and feeds.
Yeah.
We're not going to cover that for time's sake, because really when you go to make your own piece and you're about to use the mill, like you'll have to calculate the speeds and feeds because you'll have to select them. But we've kind of pre-done that, so you can take that for granted, ignore the man behind the curtain and all that. So
yeah.
Now what I'm going to do, just in terms of thought process, is we want to make this very clearly. If you bring it down, like this edge is tilted this way. And so what we want to do is make this top face parallel to this base of the vise. And so what we're going to do is we're going to position it so that we can do something similar to the mill and get this even. So the vise is tightened down. Just going to double check that. And a lot of times, if you're trying to do something precise, not just make this flat, you do a lot of stuff in terms of either setting your scales or using the digital readout here.
Yeah.
And so one example I can show you guys, let's see, we'll set the X first, or the Y first.
So right now we're moving both
and so
X and Y.
People might yell at you for doing this. It's not great practice to grab a cool of the mill, but
so you didn't see that.
You didn't see that. That didn't happen. So this is the Z feed here. And one of the interesting things on Bridgeports, these come off, so they're
quite annoying.
They do that so basically you can't like accidentally bump into it and
set off the Z.
And set off the Z, because there's a lot of leverage here. So I'm just going to bring this up.
So he's bringing it up so you can see the distance there is closing between the part and the end mill. Just going to also, oh, okay, go for it.
So I'm going to bring it up past the edge of the end mill.
Yep.
And again, this is something where you might indicate it in, you might use an edge finder if you wanted to do super precise work. I actually don't really need the DRO to be accurate. So I'm just going to bring it up and bring it forward slowly with the Y handle until I feel it bump. Bump. And then I reset the Y there. So that's 0 this way. So the 0 of the Y is on this back face. And then I can bring this across. And then again, this is super rough, not accurate.
This is not what you would actually do.
This is not what you do at all. I'm just kind of showing you guys, like this would be spinning if it was an edge finder.
Yeah.
And then I'd 0 the X there. And then as a result, now I bring the Z down. So we're at X0, we're at Y minus point, like basically 3/4 of an inch.
Yep.
So if I actually brought the Y backwards until I'm basically at 0,
there you go. So we're at that back corner.
It's hard to see.
Yeah.
But basically, this is a 3/4 inch end mill. And if you drew so you have a circle, if you drew the box around the circle, that box's corner would be touching the corner of the workpiece.
So I'll show it from this side. You can kind of see there. And then if I show it from the other side, you can also see it's right at that corner there.
All right. So now I now know if I feed it across 1/2 inch, I will take off a 1/2 inch that way. And then I also know if I feed it, however far this way, and you can see I actually have to lower the table as I come across, or I'm going to crash again. So the
Crashing
total distance, the total distance there, that was actually about 5 inches from
we can see
that face
on our DRO.
Yep. So that's 5 inches from this to off this piece. The actual piece length is going to be about, right, because we zeroed here off of this face. The actual piece length is actually closer to 4 inches, but
yeah.
Anyway, so that's that. On these Bridgeport mills, again, you have a high and a low feed. That's set by this lever here. We're in high right now. The speed you can read is here. This is low. This is high. We're at about 1200 RPM. And then you choose whether you're using the low or high range with this switch here.
Which is also how you turn it on.
Which is also how you turn it on. An important thing to note is that you shouldn't change this speed unless it's running, and that's because there are hydraulics and stuff going on. So you don't want to mess with that. So anyway, we'll get this going. Oh, no, we won't. Hold on.
We didn't turn on the machine. So here the setup is to turn on the, there we go. Okay. Yeah. Turn on the electrical power to it. All right. There's our end mill. Lower the Z.
And so right now I can see, it's hard to see. I'll actually take this on. But just this corner here is right underneath the end mill. So when I bring the Z up, it'll touch. And I don't know if you guys could hear, but you can see, I don't know if you can. It's touching. You can kind of see it. If Lisa holds the phone close like that, you'll really see as I move this. This first corner just got machined. So that's like the Z0. So I'll go down here and I'll set this scale, if I can.
To 0.
To 0.
So he's moving the scale to 0.
And now I'm going to bring the table up.
5 thou.
Yeah,
10 thou. So we're going to go 10 thou off. You might be able to see those chips. I got it.
And you can see this part here got machined, but the rest of it isn't because it's lower. So this is aluminum and it's a pretty good end mill. You may not be able to do this at the PRL, but I'm going to take a pretty big chunk off now.
So he's moving in the Z again.
We're going to take a 30 thou.
So now we're at 40.
We're at 50.
Now we're at 50.
Before we were at 10.
10. So we're taking 40 thou off.
And you can see.
So now it's super obvious.
This side, this is flat, but that's still tapered, so.
We're going back. Going over to the Z. Going to remove more material. So now we're going to, okay, so now we're going to 100 thou. This is going to be a